Hello students, today's lesson is on intercepts and point slope form. I want to first talk about how to find the x-intercept and the y-intercept. If you recall, when you look at a graph, and if you look at where the x-intercepts are on a graph, they're on the x-axis. So I could have one right here, I could have one right here, could be negative direction. Any of those are considered x-intercepts, but I want you to think about the ordered pair of the x-intercepts. This ordered pair for this x-intercept right here is 1, 0. And this ordered pair for this x-intercept is 2, 0. Any point that is on the x-axis will have a 0 value for y. So if we take this into how are we going to find the x-intercept, what you're going to do is you're going to substitute a 0 in for y. Okay, well the same thing holds true for the y-intercepts. If we have the y-intercepts over here on the y-axis, I could have one at 1, I could have one at 2, at 3, I could have one at -1, and so on and so forth. But when I write the ordered pair for the y-intercept, it's 0, 3 or 0, 2, but all of the y-intercepts have an x value of 0. So for this one, if you want to find the y-intercept, you're going to substitute a 0 in for x. So basically, whichever intercept you're trying to find, you're going to take a 0 and you're going to substitute it into the other variable. So let's first look at this first problem. 3x plus 5y equals 15. If we want to find the x-intercept, so I'm going to write down x-intercept. And when I do that, that means I'm going to take a 0 and I'm going to plug it in for y. So I'm going to have 3x plus 5 times 0, and that equals 15. So go ahead and solve it. 3x plus 0 equals 15. 3x equals 15. And x equals 5. So the x-intercept would be at 5, 0. Now let's look at the y-intercept. So for the y-intercept, I'm going to take a 0 and plug it in for x. So 3 times 0 plus 5y equals 15. That gives me 0 plus 5y equals 15. So that means that 5y equals 15 and y equals 3. So my y-intercept is at 0, 3. Let's go ahead and sketch what that graph looks like. At 5, 0, so 1, 2, 3, 4, 5, 0 is my x-intercept, and my y-intercept is at 0, 1, 2, 3. And I can go ahead and sketch the line by connecting the 2 points. Moving on to the next problem, let's do the same thing for this one. So if I want to find my x-intercept, I'm going to take a 0 and plug it in for y. So 2x minus 4 times 0. Excuse me there, that was my daughter interrupting me. So we're going to put 0 in for y. That equals -8. Let's go ahead and keep solving it. So we have 2x. This gives us 0. And that equals -8. So 2x equals -8. And that means that x is equal to -4. So my x-intercept is at -4, 0. Let's get our y-intercept. So y-intercept, 2 times 0 minus 4y, and that equals -8. So we have -4y equals -8. So that means that y is equal to a +2. So my y-intercept is at 0, 2. Let's go ahead and sketch our graph. At -4, 1, 2, 3, 4, I have a point, and at 2 on the y-axis I have a point, and we can go ahead and connect our dots, and there is our line. Okay, now for the second part of our notes, we want to look at point slope form. Well, the point slope form is y minus y1, and that equals m times x minus x1. Okay, so in order to use this form, we need to have a point and we need to have a slope. Okay, so the form pretty much tells you what you need in order to do it. For the point, we're going to plug the point, the ordered pair for the point, in for x1, comma y1, and then of course the m is our slope. Okay, so let's go ahead and work a couple of practice problems. Number 3 says write the equation for the line that goes through the point -3, 5 and -5, -2. So the first thing I want to do is I want to find the slope, because I have to have the slope in order to write the equation. So I'm going to use my slope formula, y2 minus y1 over x2 minus x1. So I'm going to take the -2 minus 5 over -5 minus a -3. Now, in a previous lesson, I showed you that it does not matter which order you go in as long as you're consistent. If you go from the second point to the first point in your y's, you have to do the same thing for your x's. So -2 minus 5 is -7, and -5 minus a negative, remember we're going to change minus a negative into a plus, so we've got -5 plus 3, which gives us -2, and then a negative divided by negative is positive, and 7 over 2 cannot be simplified. You want to keep your slope as an improper fraction because you don't want to change it to a decimal or a mixed number, because slope is rise over run, so you want to keep it like that. Okay, so now when I use my form, I can use either point. I can use the first point or the second point for my x1, y1. For this particular example, let's use our first point. So -3 is going to go in for x1 and 5 is going to go in for y1. So I go ahead and start plugging it in. So y minus the y1, which is 5, and that equals my slope, which is 7 over 2, parentheses x minus my x1, which is a -3. So minus a -3. Okay, so the minus -3 is going to change to pluses. And now let's just go ahead and simplify it. Go ahead and keep it in point slope form for now. So we just have y minus 5 equals 7 over 2 times x plus 3. And that's good enough for now. Here in a few minutes we're going to convert that to slope-intercept form. Okay, now for the next problem, number 4, it says do the same thing for the line that goes through 4, 5, and 7, 8. So I want you to pause the video, work through this on your own, and when you're ready to check your answer, go ahead and hit play again. Okay, so hopefully this is the equation that you got, y minus 5 equals x minus 4, and that's with using the first point. If you used the second point, then you would have gotten y minus 8, and it equals 1 times x minus 7, which would be y minus 8 equals x minus 7. And this is an okay equation too, but I want you to notice that if I go ahead and I simplify this to slope-intercept form, that would mean that I would have to add the 5 over to the other side. So I'd get y equals x plus 1. And if I do the same thing for this one down here, and I go ahead and get the y by itself, I would add 8 to the other side. You would still end up with the same equation as you did in the previous one. You would get y equals x plus 1. So even though the point slope form equations don't look the same, when you go ahead and simplify it into slope-intercept form, then they do look the same. Okay, now we're going to look at parallel lines and perpendicular lines and how we can use their slopes to write the equation for the parallel line or the perpendicular line. So first I want you to think about parallel lines. Parallel lines look like this. They're never going to cross, they're never going to touch. So when we look at their slopes are the same. They are equal. Okay, but when you look at perpendicular lines form a T. They have a 90-degree angle in between them. When you look at perpendicular lines, their slopes are what we call opposite reciprocals. So they are opposite reciprocals of each other. So what that means is, let's say we have the slope 3/5. Well, the perpendicular slope to that line that has a slope of 3/5 is going to be the opposite. So since it's positive, the opposite would be negative. And then reciprocal just means you're going to flip it. So 3/5 flipped would be 5/3. So if you look at two lines that have these slopes, you'll notice that they are perpendicular. Okay, so let's work an example problem. It says write an equation in slope-intercept form. So we're going to write it in slope-intercept form for a line that is parallel to this line, y equals 3x minus 1, and it goes through the point -2, 3. Okay, so what you should notice right off the bat is that if it's parallel to this line, then that means that it has the same slope. So the slope of this line, y equals 3x minus 1, is the 3, and so the parallel slope would be the same, 3. So I'm going to write a little parallel out beside it. And then we have a point, so we could call this x1 and y1, and since we have a slope and a point, then now we can use our point slope form. So we've got y minus y1 equals m times x minus x1. That's our point slope form, so let's go ahead and plug everything in. Y minus the y1, which is 3, and that equals the m, which is 3, parentheses, x minus x1, which is a -2. So minus a -2. So we're going to go back through and we're going to change that to a plus, and let's go ahead and simplify it into slope-intercept form. So we have y minus 3 equals, let's distribute the 3x plus 6, and then we're going to add 3 to both sides. And so we have y equals 3x plus 9. And there's my slope-intercept form. Now, one thing that we can do at this point is we can check our answer. The first thing we want to do is check that it is parallel. Well, if it's parallel to this line, then it's going to have the same slope. And they do have the same slope. They both have a slope of 3. The other thing that we can do is we need to check this point and make sure that it works in that equation. So let's check that point. We're going to have y equals 3x plus 9. So we're going to plug this point in for x and y. So y is 3, and that equals 3 times my x value of -2 plus 9. And let's see if that works. 3 equals, that would be -6, and -6 plus 9 is 3, so it does check out. So this is the correct answer. Okay, next, example 6 says, write an equation in slope-intercept form for a line that is perpendicular to this line and goes through this point. So once again, our point is going to be our x1 and our y1, but now we want to find the equation for a line that is perpendicular to this line. Well, this line right here has a slope of 3, but if you remember, a perpendicular slope is opposite reciprocal, so because this is positive, opposite would mean that the perpendicular slope is negative, and then reciprocal, you're going to flip it, so if it's 3/1, when I flip it, it's 1/3. Okay, so let's go ahead and use our point slope form to work out this problem. So we have y minus y1 equals m parentheses x minus x1. As you're working these problems, I want you to copy down this form before you start substituting in, because it'll help you remember it. So we have y minus the y1, which is 4, and that equals a -1/3 parentheses, x minus a negative 12. Now let's go ahead and get that into slope-intercept form by distributing and moving everything over to the right side. So we've got y minus 4 equals, distribute that negative 1/3, so negative 1/3 x. Okay, and now here's the hard part. Negative 1/3 times 12. I'm going to write that over here. Negative 1/3 times a positive 12. I want you to keep in mind that when you're multiplying fractions, you multiply the top numbers and you multiply the bottom numbers. So on the top, I have negative 1 times 12. That gives me negative 12. And 3 times 1 gives you 3. Now when you divide that, it gives you a negative 4. So when I put it into this equation, it's going to be the minus 4 on the end here. Because again, negative 1/3 times 12, I went ahead and did that here, and it came out to be a negative 4 or minus 4, and so I'm going to put that into my equation. Now let's get your y by itself by adding 4 to the other side. So y equals negative 1/3 x, but negative 4 plus 4, those cancel. So here is your final equation, y equals negative 1/3 x. And now you can go ahead and check it also. Remember the perpendicular? Yes, they are perpendicular of each other because this one has a slope of 3 and your answer has a slope of negative 1/3. Those are opposite reciprocals. And then the last thing that you want to do is check by plugging in that point. So we've got y equals negative 1/3 x. Take your point here and plug it in. So the y is going to be a 4, and that's equal to negative 1/3 times your x value, which is negative 12. And 4 does equal negative 1/3 times negative 12. And so it checks out. So you know that this is the correct equation. Okay, the last part of this notes is describe what the intercepts represent in each graph below, and remember to use complete sentences. I'm going to do number 7 with you, and then I want you to do 8, 9, and 10 on your own, and I'm going to ask that you fill in some of those answers on the whisk form that you fill out when you're done watching this video. So in this first problem, number 7, we need to describe what the intercepts are. So the intercepts are the y-intercept and the x-intercept. So if I go ahead and extend my line out, the y-intercept is going to be up here somewhere, and the x-intercept is going to be down here somewhere. So what do those represent in the graph? Well, if you look at the y-intercept up here, this is the price when the age of the car is 0. So the y-intercept represents the price of the car when it is brand new. Okay, so that's what the y-intercept represents. Now the x-intercept is down here, so that's the age of the car when the price is 0. So one way that you could explain that is that the x-intercept is the age of the car when it has lost all value. Okay, there might be other ways that you could write what they represent, but this is just one way. Okay, so go ahead and finish 8, 9, and 10 on your own, and I'll ask you to write down some of those answers in the whisk form. If you have any questions, please put that on the whisk form as well, and I apologize for this video being long. It's just a lot of topics in one video. See you at school.